Hello everyone. Today we're going to do something different, not just examining an IB style STEM question. So today we're going to talk about a phenomenon, I guess we could say a scientific physics phenomenon. So it started with the other day when I was carrying a mattress, moving it with my friend, and when I realized that when the mattress was more close to being horizontal, that's a bad drawing. Let's say this was the mattress right here, and I was holding it like from here. So that's my hand, maybe. And it was harder for it to stay still compared to when it was more like, let's say the angle was more like this. That was easier to hold it still, and obviously it felt the easiest when it was something like when it was completely vertical. And so I was wondering why. Like, why did it feel so much harder to hold it still when it was closer to almost being horizontal compared to it being closer to vertical? So I thought, and then I realized that it might be because of physics. I mean, it definitely is, but specifically it relates to torque, I think. So, and this is why. And in this video, I'm trying to explain why I think it is. So let's say the mattress is completely horizontal, vertical, I mean, like this. And since it's turning this way, that means we can say that the axis of rotation is like right here, this part, because it moves like this and then it moves like this. So that's the axis of rotation. And so let's say we look at the torque law. It's this one. So let's just write that down somewhere. The torque is force times r, which is the distance away from the axis of rotation, times the angle. Okay, so let's see why it's very easy to you don't need to add any force to keep it still right here. And it's because we know that gravity is downwards, obviously. It's always downwards. So that's the force of gravity. And so we have the force here, which is F equals ma. And so it's constant, essentially. And the radius, it's not really admissible here. It's not really applicable here. And that is because when we look at the angle here, the angle here is 0, essentially, because it's on it's in the same direction as the mattress. So, and we know that sine 0 is equal to 0. So if this thing is 0, that means the torque is 0 right now. And I just realized I wrote that as pi, which is funny. Okay, so that's the case for a vertical one. Now let's look at maybe a 45-degree angle one. So it's more like this now, and this is the ground. So as always, gravity is facing down, and axis of rotation is here. And so F is constant. The R is about the same because it's everywhere. It's not at one point. But the differentiator here is that the angle is, let's see, is this. This is the angle. And since the angle is not zero, the whole value, torque, exists essentially. And you have to exert an anti-torque for it to remain stable. Because for it to have no acceleration, no movement, all the torques have to be balanced because this is a rotational movement, angular movement. And so, yeah, this is why when it's more inclined, you have to exert more force. And let's examine an almost horizontal scenario. Okay, so let's say it's like this now. And this is the floor again, and the gravity is down as always. So force and R is constant, but the thing is, the angle is it's getting larger and larger. Okay. So it's essentially approaching 90 degrees. And we know that sine 90 is the largest value for sine, which is 1. And so that just shows as the angle increases to it being completely horizontal, torque increases because F and R are essentially constant, but sine theta changes. And this is why this phenomenon exists. I guess it's not just for mattresses, it's for like anything. So for let's say this water bottle, if it's on the floor, if it's like this, it's harder to hold, and this, it's harder to hold. So yeah, that's the conclusion. Thank you. I find it very interesting how all of this relates to like everyday movements, like carrying a mattress, like how it relates to physics laws. I find it very interesting. Anyways, bye for now.